my name is Aida. Today I'm going to be presenting about extension functions in Kotlin, about how to use them, how not to use them, and as in general, the good examples and the bad examples of extension functions in Kotlin. So the question is, why do we need extension functions, you ask? The answer is because, there is no single API that fulfills the wildest dreams of every developer in the world. And usually, the developers end up extending those APIs at some point to make our lives easier. Raise hands how many of you tried to style the text with different colors and then tried to add some superscript or some clickable URLs. How many of you tried to do that? Many of you tried. And as you know, the journey of customizing the text just ends up being a very long saga. So that simple example of 3 lines with different text colors and then clickable state, it's literally, if you're going to use square code style, ends up being more than 70 lines. Here's the continuation. And as you see, it's barely readable. But then Google introduced Android extension functions. With that, you can just use the build span string and then add the extension functions like making the text bold, adding colors to the text. If you want, you can actually use the clickable spans as well through in-span extension function. And the most important thing, you don't need to worry about the beginning and ending of the indexes that needs to get updated. How to make extension? Like, let's say we have a class, some kind of class, which is domestic animal, and we would like to make it just a regular animal that has different parameters. When you're going to extend the domestic animal to be a regular animal, you can just use the receiver type, which is domestic animal. You add the dot, and then the name of your extension function. In our case, it is toAnimal. And the return type will be the result that we want to see, which is the animal. And inside this lambda, you return your animal. Here, and then somewhere in your activity, you would call domestic animal toAnimal. And then toAnimal, basically, it's going to be extension function. It's easy to find on IntelliJ because it gives you the italic text style. How to use extensions in Java classes. So not only you can use extension functions on Kotlin classes, you can also use them in Java classes directly. But here's the catch. When you try to use regular style as in Kotlin, when you just do, hey, here's domestic animal to something, IntelliJ will not find you an extension function. In order to do that, you got to go to your file that contains all your extension, contains the extension function, and then click on Tools, Kotlin, Show Kotlin, and then click on this Decompile button. That will tell you the name of the class in Java, which in our case it is mappers KT. And then in our activity, Java activity, we can just call mappers KT.toAnimal, and then pass our receiver, which is domestic animal. Yep, this is the example. Now, there is only one case when you cannot use your extensions in Java code. When any kind of extension function that has annotation inline only is not able to use them in Java code, because inline only, it means that you're referencing to the private method of Java code, therefore it's not going to be exposed to you, so you won't be able to use it in your Java. Now let's talk about some common practices. Here's a little disclaimer. It is my own personal opinion about how to use and how not to use extension functions. So there are some sad examples of using extension functions. The most common one I see it is when you apply business logic and then just common types of Java and Android all together. You say, hey, I have here a string, and I want to make that string to be my business logic, which is animal, that kind of case, it messes up a lot. If you think about that, you're assuming that every kind of character technically can become an animal. Char sequence can become an animal, which is not, doesn't feel right. Instead, I would recommend to do the extensions from business to business or from common to common type. That's easier later on when you move from one project to another project, so you can just copy paste your extension functions and put them in a different project to use. Here's an example with animals, again, from wild animal to regular animal. And this is the example of the inline as well. When you have string as a common type, you're converting into pattern, again, common type. Another example is when you're modifying your member class of the receiver. Let's say we have an activity, right? And then you decide, okay, I would like to display a loader on my activity. And then for some reason in your extension function, you decide to increment the loading indicators every time when the loading is displayed. So this is the extension function that you're going to be doing. And then technically this indicator is a member variable of your class that you're extending. This is not a good example of modifying the members. I would recommend you instead just to make a regular member function. There is nothing wrong with using member functions. Now, the next one is when you use the same name as a member function. When you create your extension function has the same name as a member function. This, you think it's okay, it may work, but in reality, when you're going to run, what's going to happen is that member functions will always win over extension functions. So I would recommend you just rename it to something else that is comfortable, readable. Now, the next one I noticed, everybody likes to extend context for some reason. If you look up on Google, like if you type in like extension functions, examples, blah, 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 when you start to begin, you notice how everybody in the examples tries to extend context. My question is always like, why context? I analyzed it a lot, and then I found out that when everybody gives you, tells you like how to start with extension functions, they will tell you, hey, you know what, you can start small, you have a util class, you're gonna get these methods from your util class, convert them into extension functions. The idea sounds good, and then in reality, in your util classes, in all these methods inside the util classes, you just keep passing the context basically for everything. And so people just extend the context and make functions, which is, I would say, just doesn't feel right. It kind of, I cringe every time when I see this kind of code, and I'm like, basically, if you're going to look from an Android perspective, everything in the end of the day is a context, right? Like all these major components, they extend context wrapper extends context. But in reality, you can simplify, like, try to extend the view that you're passing to your extension function. If for some reason, like let's say in your extension function, you're passing views, better to extend that view instead of extending a context. Another case is when we try to draw something and we like some kind of view and which we extend the context again. This is an example of what I saw too, like when we try to display the dialogue and we extend the context, we think, oh, it's cool, activity is taking care of that, we're checking if activity is not null, and if activity is not finishing, we would like to display dialogue. But it's better to just extend the activity. Oh, something's happening. Better to extend the activity, because that way you have access to the context itself and also to the window manager that is responsible for drawing a dialogue for you. Now, if I'm gonna wrap up about some good practices in general, how to make extension functions, I would say the number rule that I use usually it's try to make a type conversion, but it's from business to business, common to common, most important thing. In this example, let's say we have a type map, and it returns array list. And then the second type is interface conversion. So again, you have a map interface, and I want to actually convert into sequence interface. That way, I can use the extension functions. And the next one is, there are many components in Android that technically are kind of view groups, like combine the list of something, and most of them, they miss iterators. And for that kind of case, it's always to have iterators as an extension function. This is the example from Core KTX, so this basically menu, it contains menu items, and it iterates through the menu items. And the next one is nullable receiver. So main pinpoint about extensions as well, that you can catch the null before you display, before you access to it, basically, and you can hide this behind the extension functions. So you check, okay, I have a string, and if it's null, then I will just check if it's other equals null. Otherwise, I will check if my string 1 and equals to the string 2. So if you're going to look up in the documentation, you will see that Kotlin standard library has a lot of extensions. Basically, every class that you go to in the kotlinlang.org will have some extension functions. All you need to do is just scroll down. It's all the way on the bottom. It will say extension functions. It's really helpful to just look around, see what are the good examples that they use to make an extension functions. And also, in the recent versions of Android Studio, I believe it is 3.5, Core KTX actually comes out of box. It actually implemented right away for you, so you can start using build span strings, or spannable string builders, or animations like do animate extension functions right there out of box. But if your code is older, then you have to manually import them. Okay, so in the references, it's Kotlin documentation, Android developer documentation for Core KTX, and I also used some of the examples from Jake Wharton's presentation about Core KTX. That's about it. Thank you very much, all.